being a good science communicator, being a good science teacher is so important for everyone, not just the people who want to study science. Think about ways to actively teach your students to be more like scientists so that they can understand how to think like a scientist and how to ask good questions and how to make good observations and how to design experiments and investigations about the natural world, whether it's second grade or whether it's high school, 9th grade, or whether it's college. Being a scientist still follows many steps, many rules, and we want to help you come up with the best techniques to do that effectively so that the students learn to develop their own science knowledge instead of us just talking to them and lecturing them and telling them to read the textbook and say, memorize this fact.
Inquiry, there are multiple levels of inquiry. What we see, and Heron put together this really cool table of how to help you decide what kind of inquiry you're doing with your students. And the key is not to do always the same level, to do multiple levels. And the ultimate goal is to eventually do the open inquiry level, which is actually a closer approximation to what real scientists do in the real world. Okay? And Heron basically said there are 3 major aspects to inquiry. Those include, did the teacher supply the question, the research question? Yes or no? Did the teacher tell them how to do the procedure? Yes or no? And is the solution known in advance? So if the student goes into an experiment, the teacher says, okay, here's what we're trying to do today. This is how you're going to do it. And we're just going to confirm that this is correct. We see it a lot in chemistry classes in particular, a lot of confirmation type activities, biology. In fact, you're going to get one today that is purely a confirmation activity. Although it's inquiry, it's considered the lowest level of inquiry and requires the least amount of critical thinking. So what you're looking for is a situation where eventually the students are coming up with their own question, they're coming up with their own procedure, and they don't know the solution at the end.
So many teachers just have so much work to do, and sometimes they feel that it's hard to do open inquiry because they're told you have to teach this and this and this. So if they can do the upper level, do a structured inquiry or a guided inquiry, it helps them to do the content of what they're supposed to teach, but the students are learning the science better that way.
People don't conserve anything unless they care about it. And the only way you can get people to care about something is to teach them about it, let them learn about it, let them know about it. And sort of a corollary of that, for me anyway, is that the most effective conservation education is not to mandate, conserve this, conserve that, but it teaches about the intimate lives of organisms, about the nature that is all around us. So my approach to conservation is sort of indirect. Over the years, I've had lots of students, young ones and older ones as well. And mainly I try to get them enthusiastic about nature by talking about it, telling them about what goes on, and having them realize that these organisms that you see, little beachos you see on the beach, have very complex and interesting lives. And they're worth, for that reason, they're worth caring about and conserving. The discovery and understanding about the natural world is accessible to everybody. It's not something that only a scientist in a research lab can do.